my first panelist here. I've got a group of 3 panelists. I've got Taz Soto from the Karuk tribe, Bill Chesney, and Morgan Knechtel from Fish and Game, and they're going to get us started by looking at the population status of the coho in this particular region. So if the 3 of you could come on up, let's get going.
My name's Taz Soto. I work down in Orleans. I work for the Karuk tribe. We do surveys for coho salmon and other species, but today's talk's going to be about coho. I kind of had to pare down my talk a little bit. Usually I got a little more time, so I got about 7 minutes to get this out. So I'm going to go pretty fast. I'm just going to go through 5 slides. I'm going to be talking about the Upper Klamath population. So my first slide here is just a kind of a map to kind of show you where we're at. We're here in Wairika on the Shasta, but this is half the camps down here. This is roughly Syad Valley's here.
Pause, hold on 1 second. Sorry to interrupt. We can't hear you in the back. So would you rather have a hand mic? Sorry.
Sure. Hello. How's that?
Is that better?
Okay. Good. So this is the main stem Klamath up to Iron Gate Dam in this neighborhood. Here's Bogus Creek, Shasta, Scott. So I'm going to talk about this area here. This is the Upper Klamath population. I commonly refer to it as the Mid Klamath. But our surveys are pretty limited. We do a red count. We walk or we snorkel. These are our surveyed streams: Syad, Grider, Horse, Beaver, Humbug, Main Stem River. We float the Main Stem River a few times, but we don't really have very good coverage on the Main Stem. Our best coverage is here on Syad Creek and Lower Grider Creek, and then we've got 1 year good data here on Lower Horse Creek. But we don't cover Cottonwood Creek and some of these larger tributaries up here, Willow Creek, and then Morgan's going to talk about Bogus Creek up here at the top. So anyway, that's the, oops. Wrong button. Sorry about that. There we go. Yeah, I'm right here. So this is just a summary table. When you look at this, you really see our effort has gone up through time. That's the main thing. My big point is there's not a lot known about the Upper Klamath population, and our effort is increasing. You do see an increase in reds, but that's likely just because our efforts increased. And this particular year here we had 52 fish. Live fish we encountered, and that's mainly because we did a lot of snorkel surveys that year. So I think the red counts probably our best indication of what's going on. And then we find very few carcasses. The fish are spawning in the wintertime, and the predators are out there, and coho carcasses are hard to come by. So I put together this a few days ago. This is just reds per mile through those years, and you see a little bit of a trend. We have a stronger year in 2007, and then a low year here in 2009, and then it bumps back up 3 years later, 2010, and then 2011 is a little weaker. But you see this pattern. I'm sure Bill and we'll be talking about this on the Shasta a little bit. But just the kind of general trend there between years. Timing, the fish in the upper population, we start to see them in mid-November, and then peak spawning is usually right in here around the first week of December. These blue dots are new reds counted, and you see a little bit of a peak here, and then generally by January 1st, we're not seeing new reds and just a few carcasses, and it's pretty much over. So it's a pretty short period. It makes surveys pretty tough. And then I just wanted to put this up here. This is a comparison between upper and then the middle population as far as timing. And you see the upper population starts a little earlier. These are new reds encountered. And then the middle Klamath population, which goes basically from Syad down to about the Trinity, you see a little later, about 2 weeks later here. And most of these fish are actually Aikens Creek, Camp Creek, down in the lowest part of the river. This is River Mile 45, and most of these dots are from River Mile 120 and up. So there's a little separation, but in general, the peak occurs around the same time, about the middle first week of December. So just to kind of finish it, the population is pretty small. It's spread out. We have pretty low coverage. I'd say we cover probably less than 30% of the total available habitat as far as our red survey. So, you know, we don't have access to a lot of areas to survey. Winter conditions are really challenging. So with that, I'm just going to say we don't know a lot about the Upper Klamath population other than what we have here. So I'm going to pass it off to Morgan right now.
Okay, so listen, my name is Morgan Kneckley. I work with the Fish and Game Department here in Wairika. Met a fair amount of the folks in the room here. It's nice to see everybody coming together. Obviously, we care a lot about the watershed here. In the watersheds here in Siskiyou County, it's nice to see the interest from out of the area as well. So I'm going to talk a little bit about the adult and juvenile estimates in the Shasta River, Scott River, and Bogus Creek also. And we'll go from there. I've got going to try to throw a lot of information at you guys. Don't have a ton of time, so I'm just going to try to roll through this pretty quick. Essentially, the adult estimates that we're trying to generate are largely based on the utilization of weirs. We have main stem weirs. Here's a picture of the Shasta weir and aerial site. We've got the resistance board weir over on the Scott River, and then the Alaskan weirs both on the Shasta River and Bogus Creek. Okay, and looking at the juvenile production estimates, the Coho smolt estimates generated from the rotary trapping on the Scott and the Shasta rivers. We certainly want to take the opportunity to thank the Shasta Valley RCD for their cooperation in that effort. We're looking at trying to get weekly estimates of the number of 0+ and smolt coho as they emigrate out of the Shasta and Scott rivers, generally from February through July. Okay. We're not going to talk too much, going to try to not talk too much more about the methodologies. It's the standard methodologies that we're incorporating here to generate these numbers, okay? Try to use the time looking at the data. So here's the first data slide looking at Bogus Creek. You can see that there's not a ton of fish. There are some fish. We definitely do have this 04, 07, and 10 brood year. Just we have the discrepancies in brood year strength that does occur at Shasta River. I mean, on the Bogus Creek, it's not quite as strong as the other two rivers, but something to point out here is the depensation threshold for the Upper Klamath unit, of which we're making the assumption at this point the Bogus Creek is the largest piece of that demographic pie. For folks that are not the depensation threshold is a value that the NOAA Fisheries has described in terms of abundance levels when recovery becomes more difficult and challenging. Okay, when depensation effects start to take place, and some of the concerns are it's more difficult for mates to find each other in the watersheds due to densities, and populations are so low that predators actually have an opportunity to significantly impact the abundance. Okay, so we're definitely below that level there. We're close in a couple of in the one brood year. We're close, and then we haven't married this Bogus data with this information that Taz has provided for downriver, but chances are, I believe that we're still below that depensation threshold. So, okay, so another thing that we're going to be talking about a lot over the next few days is the proportion of hatchery origin spawners on the natural spawning grounds in natural areas. And it's an important metric in terms of evaluating hatchery impacts and fitness levels and whatnot. And you can see that the proportion of hatchery fish in Bogus Creek is kind of cavitated around 30%, but in 2011 you'll see the spike up to 75%. Just a little caveat, all the 2011 data is preliminary at this point. I've tried to put asterisks on there, but in any event. Okay, so let's see, you can't quite see the top of there, but we're moving over to the Scott River watershed. Here's, you know, where the watershed hits the Klamath River up here. We've got the fish counting facility roughly river mile 18. So we're counting everything upstream of there really well. There are main stem foot surveys and tributary surveys downstream of the counting structure, estimating that piece of the puzzle. So I think we have pretty good coverage over on the Scott River. Kind of diving into the data, you see the first thing that jumps out again is that 2007-2010 brood year. It's considerably stronger than the other two. And you'll see we'll throw the depensation value up there at 441 that's been identified for the Scott River. We're above it for the one brood year, but below it for the other two. Another thing that we would like to point out is that sort of, you know, this jump from 63 in 2008 to 350 in 2011, that kind of caught us by surprise. We weren't expecting that by any means, and you know, the 2011 number is still preliminary, but there's more to be told on that story, I'm sure. But that is a sign of optimism in any event. Okay, so we're going to try to marry some of the data in terms of the adults that return and the smolt yearling or the smolt coho produced. Okay, and so we don't need to dive into this too deep, but essentially this is looking at the smolt to adult survival, so sort of the out of Scott River impacts, you know, from the mouth of the Scott River on their migration down through the Klamath, out in ocean entry and their entire marine life, and back to the Scott as adults. Okay, so we're looking at an average percent smolt survival of 3.46, which is, you know, well within the normal range to be that we would expect to observe. I mean, I would say it might even be a little bit high. Some of these, the 3.46 doesn't include that 16.1 for which we're still kind of trying to narrow in on that number a little bit for the most recent data point. But something I do want you to take away from this is the ability of the Scott River to produce smolt coho. I mean, you look at the strong brood year, when we have a lot of adult fish in the system, I mean, it can produce 75,000 smolts. It's an incredible amount of fish. The 62,000 again in 2009, the smolt year. So the habitat's there at least to produce that many fish given the opportunity. Okay, so. And then looking at the freshwater productivity, the number of the adult to smolt production, just kind of trying to use this as a measure of freshwater productivity over time to be able to gauge how well the recovery efforts are taking or whatever, and put context into the numbers. And essentially we're looking at, it takes, you know, the average number of smolts produced per adult is 36.4 over on the Scott River. Okay, now we're going to shift over to the Shasta a little bit. You can see the counting facility is right down at the mouth of the river. The counting fence is roughly 700 feet from the Klamath River. So we're getting, I'd say, excellent coverage there in the majority of the years, and we don't get blown out. Let's see if we can pick this up here. Okay, so here's the Shasta River coho adult estimates going back to 78 to 2011. You know, there's kind of a gap in the middle here where there wasn't a focus on trying to estimate the coho abundance. You know, the project has historically been a Chinook focused project. So there's some years in between 82 and 2002 where only a portion of the coho run was captured. But we feel pretty good about the data before and the data afterwards. And the main thing I'd like you to see is that prior to 81, and this 81, again, we're not terribly comfortable with this number. The counting fence blew out a couple times in November and December in the 81. But the main thing is that prior in the late 70s and early 80s, we had three relatively, I don't want to say intact, but three brood years of relatively, well, numbers over 325, you know, or it's not, I wouldn't say it necessarily stable at that time, but the significant discrepancy in brood year strength doesn't really take place until after the 2001. So I think it's fair to say that what broke this apart took place sometime in the last 25 years or whatever. And here's the depensation threshold for the Shasta River. It's at 531, so we're well below that in every brood year, okay? So some of the things from the telemetry work, Mary Olswang's work in the Shasta Rivers, when they've radio tagged adult fish as they've come into the as they've come into the mouth of the Shasta Rivers, identified 2 key spawning areas for coho in the Shasta, one down in the canyon and another up in the Upper Shasta Spring Complex. We'll be talking about that a little bit more over the next couple days, I imagine. So, you know, not to belabor this, but this is kind of part of the reason why we're here, just kind of auguring in on the cohorts on the Shasta, sort of looking at cohort 1, you know, just in 3 short generations, we're looking at a 85% reduction in abundance. Looking at cohort 2, a 30% reduction in just that same amount of time. Cohort 3, this 95% reduction, okay? So, not to paint the doomsday, but this is why we're here, right? And so, also, again, looking at the Shasta River, the proportion of hatchery fish in the natural areas, we've had, you know, this 2008-2011 brood year, we've had a considerable influence of hatchery fish, you know, over 70% in both of those years. And even in the other years, the 9 and 10, over 20% is pretty significant in terms of hatchery influence, okay? And so we'll play the same game over here on the Shasta River that we talked about a little bit with the Scott. And again, the take-home message is the survival out of basin is about 3.3%, pretty consistent with what we had over on the Scott side, at least what we observed over there. So that, you know, that makes sense. These fish are experiencing, I would say, relatively similar conditions outside of their given watershed. So that's a good thing that at least the data points are similar. But here we go, looking at the freshwater productivity on the Shasta. It's not as high as for the 2 years of data that we have over on the Scott. If you average this, we're looking at 18.4% for the number of smolts produced per adult returning fish, okay? And we've had it as high as 38% back in brood year 2001. And you notice this 4.4 and 5.6, the 2 lowest observations, also occur at the lowest adult abundance. And that could be some of the depensation effects showing up in terms of there and the decreased productivity of that brood year just because of the lack of fish that are there. So we've had a range of, you know, 4.4 to 38 in terms of the number of smolts produced per adult. And okay, so let's play the game of, well, what does that mean, all right? What does that really mean? It means that we've got a negative growth rate in terms of this population. If we, just as an example, if we start with 100 fish, and we say, well, there's 18.4 smolts produced per adult, and then we multiply that times the out-of-basin survival of 3.3, well, we end up with 61 adults. Well, we take that 61 and we plug it into the next line, and we say, okay, well, we've got 61 adults, we've got the 18.4% smolts and the 3.3% out-of-basin survival. Now we're down to 37. And so in just 2 short generations, we can go from 61 to 22. And so this number here is relatively, I don't want to say good, but it's well within the normal range. And so, but we're still continuing to auger deeper and deeper down in our abundance trajectory. So what is it going to take in terms of our freshwater productivity to create a stable population in the Shasta River? Well, it's 30. You know, if you start with 100 adults, you need 30 smolts to be produced per adult to equal this 99 in terms of the expected adults. So, and the thing that's optimistic about that is that we've had a data point in the recent past where 38 smolts were produced from one adult. So it's within our reach in terms of being able to get this watershed back on a trajectory to expand the population. But in the recent past, it hasn't been there. Okay, so I think that's my last slide. So I'm going to pass it over to Bill.
Good morning. A beautiful day to talk about fish. My name is Bill Chesney, and I've been fortunate to work on the Shasta River since 1989. I'm going to talk a little bit, it's a little bit different than what you've got on your agenda. Morgan's covered the juvenile production. I'm going to be talking about distribution, migration, and survival of coho, and what we've learned about that in the last few years. Once again, overview of the watershed with the the canyon reach, which is where we see, based on the radio telemetry, where a lot of the spawning is taking place, or a portion of the spawning is taking place, and the Upper Spring Complex. It's worth mentioning that Morgan was talking about the hatchery contribution to the Shasta with this last year, where we saw like 70% of the returning adults from the hatchery. We pit tagged those fish before they were prior to being released from the hatchery, and of the 18 fish that came back, I think there's 17 fish that were hatchery origin that came into the Shasta after their release. 17 of those 18 fish remained in the canyon. Only one of those fish made it to the upper watershed. 16 of those fish were males. So I almost want to look at these two populations as two separate isolated groups, at least for spawning purposes.
Bill, could you please clarify for the folks from out of basin where the hatchery is and how far away the hatchery is?
Yeah, so here's the Klamath River, and I think the hatchery is at mile 189, I think, on the Klamath, and I think the Shasta is at 10, 15 miles downstream of that.
177. Yeah.
What's that?
177.
177 on the Shasta. So we're downstream, what, 15 miles or so? Anyway, the Shasta River, going back to the nature characteristics of the watershed, we've got about 40 miles of watershed between the mouth and Juvenile Dam. Public land is in the canyon, the lower 7 miles. Virtually the rest of the watershed is in private holding. But the focus for this talk today is going to be on the Upper Shasta Complex. So you'll see a chart, you'll see numerous maps of that, and that's where that's located, is within that black rectangle. Oh yeah. So down in the southeast corner of the watershed, there's this feature that has a large effect. Not only a beautiful to look at, but affects the hydrograph of the system. That's Mount Shasta, 14,000-foot volcano. So the precipitation on the mountain then is in the form of snow and rain, and it'll infiltrate the volcano because of the material that it's made from, and appear as a spring flow around the area around the base of the mountain. So look into the watershed. The watershed is to the northwest. So we've got a series of springs that play a crucial role for Coho life history. Water produced from these springs is typically in the 13-degree range. Optimal range for water temperatures for Coho rearing is 8.5 to 15.6 degrees, I believe. So 13 degrees is right in the smack in the middle of optimal range for Coho. Couldn't be better. The springs come in a variety of shapes and sizes. I'm going to start with up at the top here with Big Springs Creek and work my way south. So Big Springs Creek is the largest of the springs. There's an aerial shot. The water originates, there's a fracture in basalt at the top of that impoundment. The impoundment is controlled by a dam that was built down here. But Center for Watershed Sciences and Watercourse Engineering, which Mike and Carson will be spending some time talking about Big Springs Creek, but a large feature with a flow of probably, historically they said it was 120 cubic feet per second year-round. I think modern measurements are more closer with changes probably to groundwater pumping. We may be looking at 80, 90 CFS. Those guys will have the exact number on that for you. But it's a large spring. Clear Springs on the Upper Shasta River, on the other hand, is the other end of it, is about 2.5 CFS of 13-degree water, but again provides exceptional rearing habitat for Coho. So downstream of Clear Springs, it's a short distance. I just want to give you a sense of the habitat that's created by these springs. There's some leftover remnants of beaver dams that have created a impoundment structure that results in this slack water downstream of the spring. This next photograph is taken right at the base of this tree right there. This is an idea of the kind of habitat that's created. This was taken in March of 2009, prior to these fish emigrating in smolts. So there's food, there's cold water, it's the kind of habitat Coho are looking for. Kettle Springs, moving south, a small spring, again about 5 CFS. produces cold water again in the range that the fish are looking for. Come on. This is the outfall pool below Kettle Springs, which again fish are utilizing. If there's one slide that can characterize the Shasta River, this would be it. This was a slide prepared by Bill Bennett from the Department of Water Resources and presented at the Lower Basin Conference in 2004. On the left, we've got mean monthly flow in cubic feet per second. And we've got the month, so these are average, these are mean monthly flows for a period of years. The blue line represents the unimpaired or the full natural flow, the estimates of the full natural flow. You'll see different estimates. Different people have compiled trying to calculate the amount that's used in consumptive use. But in general, the profile and shape of these curves are all the same. Just to point out a few things, the bump here, the late season bump here, for people coming from the northwest or the coast, that's a snowmelt hydrograph as opposed to rainfall. So you've got your stored water coming off. And then sustained flow out here in late summer is the result of these springs that we were talking about. The red line represents the start of the irrigation season. The difference between those is what the fish are coping with. So species like coho and steelhead that have an extended freshwater life history are feeling the effect of that, which is why these populations are struggling. I want to run quickly through just some of the results of a study that we began in 2008 and 2009 on the Shasta River. Our objectives were to determine the location and thermal characteristics of over-summer rearing habitat in the Upper Shasta River that would be utilized by 0+ and 1+ fish from brood year 2007. And we wanted to determine the behavior, time, and migration of rearing from rearing habitat, estimate the probability of survival of 0+ and 1+ coho in the Shasta River. This final report is available on the Shasta Valley RCD website, so you should be able to get a copy of it there. If not, I'd be happy to get you one. So the second portion, estimating probability of survival and distribution, was accomplished through the use of pit tags. So I was fortunate to work with some very talented and gifted folks. This being one of them, Chris Adams, who's back here. Chris has done some remarkable work with this technology and allowed us to be able to get some real understanding as to where these fish are and their survival and what's affected them. So Chris is currently working as a student over at Humboldt State, and he's continuing to work on this project. So we'll talk a little bit more about it. But the idea was to capture fish when they were in the 50 to 60 millimeter range. I think 60 was your cutoff for tagging. Implant a pit tag, so passive integrated transponder, which is a discrete, unique number that each fish would carry with them. Once the fish is tagged, the tag stays in them for life, and we are able to tag them, are able to identify them both as juveniles as they move through the system, and also as returning adults. So the follow-up, this is Chris's thesis, is he's working with brood year 2010. The fish that are currently in the system right now that will be leaving in a couple weeks here in March. He's added additional stations with improved detection capabilities, and he's tagged many more coho prior to migration into the springs. So these are things to look forward to. I want to just step through the early life history as we've seen it both in 2000 and for brood year 2007 and brood year 2010. We had 44 adults return to the Shasta River, going back to Morgan's talk. Spawning took place in November and December of 2010. And the red areas here indicate where spawning occurred. So this is a composite of both from 2008 through 2011. So there's actually 4 years of data here. It's a little bit different from year to year, but in general, we see coho spawning below Big Springs Creek, in the lower end of Big Springs Creek, lower Parks Creek, the Shasta River above Parks Creek, and Parks Creek up in this portion of the watershed. Early life history for fry emergence now and dispersal, which took place in April and May of 2011, looks real similar to that distribution of spawning. Fish come up out of the gravel, the water's cold, habitat is there for them to rear as emergent fry. So you'll see again coho rearing in pretty much the same locations below Big Springs Creek, lower end of Big Springs Creek, and Parks Creek up in here. Little different from year to year. Some of this is not a complete, comprehensive, I guess, look at the watershed. We didn't have full access to this portion of the watershed. Not really too clear on what's going on, but we're certain we've observed fish in these locations. So the next step is migration to summer rearing habitat, which occurred from May to June in 2011. Now fish are moving into these spring areas to find cold water that's in their optimal range. So we see fish moving from out of the fish that had originally been tagged down in here are now moving into Big Springs Creek. Likewise, fish are moving up into this portion of the watershed. We had additional flow. Water year 2011, you remember, was real wet. So we had things happening in 2011 that we hadn't seen in a while. So we actually were able to get access, as well as we had water, additional flows up into below into these springs here, very close to Juvenile Dam. Don't have a good sense of what the distribution was in this portion of the watershed, though I do understand that there were fish rearing in Parks Creek. There were, again, at the outfall at Kettle Springs as well, too. Fall redistribution. This fits well with the model that Larry Listell has been working with in terms of these are classic, like coho movements and migration to different habitats at different seasons. So in the fall, fish now are no longer locked in on these areas where the cold water is. They're able to redistribute to where they can go anywhere in the watershed they can. They're not limited by the cold water. And so what we see in fall and November, or October and November of 2011 is fish redistributing pretty much throughout the entire watershed. This is confirmed by tag data that from Chris's tags, as well as from observation. So at this point in time, you've got fish pretty much all the way throughout Big Springs Creek, clear up to the springs. I'm not sure how much further they are above this particular spring, but just take it that coho are no longer limited to where they can rear, but throughout the upper watershed. And then we've got winter rearing occurring, which is about to end, and then we're right on the front edge of this smolt immigration, which is going to take place in a couple of weeks. So going back to the 2007 study and what we learned from that, we had antennas out for only a portion of this. This is the improvements to the study that's going around. But Chris had antennas out between this reach and the mouth that's marked by the yellow arrow. Fish that had been tagged earlier as when they were 50 and 60 millimeters eventually made their way into this location. So we had a network of antennas up here, and we had confirmed survival of these fish prior to their emigration. We had probably, all these fish had been recently detected, so we're going to make the assumption, I don't think it's an assumption, we had confirmed that they were alive at this point in time prior to their emigration as smolts. So on this one segment of this migration, it's about 36 miles, 37 miles, the fish encountered low flow. This is taking place at the same time irrigation is going on. So at this particular location, we probably had less than 2 CFS. That was the Shasta River at that point. And downstream at mile 36, there's a beaver dam that had been constructed during that previous fall. Beaver dams, as you know, create wonderful coho habitat, but this is a beaver dam below a man-made dam. So any kind of a spring freshet that would have typically occurred is being interrupted. So opportunities for this to be breached and allow the fish to have passage through it, they don't exist. So fish are having to migrate. You can see how low the flow is. Water temperatures within the impoundment are about 55 degrees. Daytime water temperatures below the impoundment are close to 75. So fish are having to encounter not only extreme range in temperatures, but also low flow. You can imagine that the survival through something like that would be difficult. And that's what this next diagram shows. If you started with 100 smolts at the top of this reach, this is the upper start of the segment. This is the mouth of the river. If you started with 100 fish here, 84% survival to the first antenna, which is about 0.5 miles. 68% survival to the next antenna, so your 100 fish in a mile and a half is turned into 57. And by the time you get to the mouth, you're 46. So you've got pretty close to 55% mortality on these fish in a 3-day migration. This encompasses the entire tag group for the entire 2-month period, but the actual individual fish would only take about 3 days to do this. So using one of Chris's cool animated slides, it would look like this. We start with our tag group at the top, and oops, let's do that again. And by the time they reach the mouth, we've lost almost 55% of the fish have been lost to mortality. They've survived 18 months in the watershed. They're 140, 150 millimeters. They've got everything going for them, but we didn't give them the chance to get out of the system. So, missing pieces from that 2007 study. These are smolt survival estimates. They were only available from one location, from that upper portion of the Shasta River. And we didn't have survival through other life stages of migrations, as in egg to fry or fry to smolt, or from other portions of the watershed. So, but these are pieces that I think Chris is going to get a handle on this next go-round. So findings from the Shasta River studies are that distribution of rearing of juvenile coho changes seasonally, that regardless of where coho emerge from the gravel or rear during the summer, they will be widely distributed throughout the upper Shasta River prior to emigration of smolts. This is a really important point, because no matter where you start, they're not going to identify or recognize property boundaries. They're going to be all over the upper watershed, as they should be. Smolt emigration is underway when irrigation season begins, and successful smolt emigration requires suitable habitat conditions, as in flow and temperature, throughout the entire length of the migration routes. We talk about the idea of one bad day or one bad reach is all it takes. So you can have an animal that's made it through all these different hurdles or challenges, but if you encounter a period where there's limited flow and or extreme temperatures, it's game over. So this is what it looks like right now. We're 2 weeks prior to the smolts leaving, and I'm confident that this is what looks like the distribution. So if we have successful immigration out of Big Springs Creek, which I'm certain that the flows are going to be suitable and temperatures are going to be good to allow that, that's only a portion of the production. Back to Morgan's idea, we want to get 38 smolts per returning adult. We know in some years we've been able to do that. We don't get it in all years, and I think it's because of some of the variable conditions that they might encounter. So the goal is to figure out what does it take to get survival out of these other regions.
Okay, thank you very much. Can we thank all three of our presenters here? Okay, well, we have a few minutes for questions from other researchers or resource professionals. Again, public observers will have time for questions at the end of each session. If you've got a question, put it up on the question bank there. We can all see it, and hopefully we can get it answered sooner than the end of the day. So I am going to have to keep this fairly short. So my encouragement is heart-pounding questions. Okay? Got to clear up a major piece of data or interpretation. So go ahead, please.
There, I have a quick question for Mr. Chesney. The graph that shown, the DWR graph showing the discrepancy between natural flows and irrigation season flows. Given that the river was fully adjudicated in 34, is it the understanding that discrepancy has been true since essentially 34, or perhaps even before that?
I would expect it was, yeah. And then in terms of the years that were used to prepare that chart, I don't have that information. I know it's a number of years. Bill Bennett's going to be working as a water master up here. When Bill's up here, I think we should ask him about the origin of those numbers.
Okay, I guess the question comes really full circle to, it looks like in the past 25 years, as Morgan pointed out, is we lost out on at least 2 of those brood years. It seems hard to pinpoint irrigation flows as a problem if they've been going on since 34, and whatever the impact was that caused that 2 brood year discrepancy was a last 25-year issue.
I think there's a multiple factors that are come into play here, but flow is certainly one of them.
Thank you.
Okay, thank you. Who else has a question? Heart-pounding question for our panelists. And if you could just please briefly introduce yourself for the rest of the audience. They may not know who you are. Thank you very much.
I'm Eric Loudenslager from Humboldt State, and I was curious as to whether you know what the actual egg to smolt survival is for the coho, or the number of smolts that are getting ready to emigrate per female?
I don't think we have the egg to smolt values. It's a piece of the puzzle that's missing.
But is there so you're doing a smolt estimate at the lower end of the Shasta River? That's where those smolt counts came from?
The rotary trap is located at the mouth, yeah.
Okay. So we have smolt survival estimates just from the study that Chris is doing,
That's right.
but no smolt abundance estimates from the whole system before they start to emigrate.
No, our estimates are generated as they leave the system at the mouth.
Okay, I see another question up here. Go ahead. Mia, do you want to give? Thanks.
Rich Carmichael, Oregon Department of Fish and Wildlife. I was wondering if you could more clearly articulate what you believe the mechanisms of mortality are for that mile, I think it was 1.5 mile reach that accounted for 45% loss of the fish. I know you mentioned flow and temperature, but specifically what biological mechanisms are you hypothesizing are causing that level of mortality?
I think it could range from predation as these fish are moving through. It's probably temperature may be playing a factor, playing a role here as well. I think it's important also, thank you for asking that question, to come back to that portion of the show, because we don't know what the mortality was on other portions of other migrations. So I'm not saying that's typical of all migrations, but it certainly illustrates some of the problems that these fish are going to be encountering as they leave. So my guess, I would think possibly stranding, predation, and exposure to temperature extremes might be some of the factors I would indicate.
We have time for maybe one more question.
Question, this is to Bill. Larry Listel, I'm a consultant working with the tribes. Bill, could you comment on what your thoughts are with regard to the possibility for zero-age smolts coming out of the Shasta?
Yeah, Larry, it's something that it took us a while to figure out what the heck we were looking at, but after the end of May, we see fish leaving the watershed, some years more than others. That as it turns out, they're smolts, but it turns out that they're large, fast-growing zeros that have reached the size. Larry, you've done some of that work up in Washington where you've identified this occurring. We think it's the result of conditions that allow fish to get up to size to smolt. Chris has, I think, tagged a couple hundred of these fish from brood year 2010 as they leave the system. I think some of the efforts by the Karuk and the Yurok downstream looking for these fish in some of these main stem refugial areas will give us some insight as to whether these fish are actually smolts or whether they're just zeros leaving and looking for a place to go. But they certainly, I think we're hoping that from the number that Chris tagged, that we should be able to get some returns on some of these fish and see what their contribution is. It's an unusual, you don't see much information about 0+ smolts in the literature, I guess.
Well, let's thank our panelists again one more time. And up next we have Jim Seamonday from the National Marine Fisheries Service.